Hello, my future champions. Today I will teach you why, if any quantity proportional to other quantity, then why there is a constant we write like this. Actually, I told you, even in these days, many of the students just cramming the steps, the formulas, but they don't understand the exact meaning of those steps. Today here I will teach you why we use this constant and why after eliminating this symbol we use equal to sign. Okay. In high school physics, you must be read this. Voltage is proportional to current. Suppose there is a circuit. Suppose there is a circuit and it is resistance, current, and this is battery of V volt. Okay. So from this equation we can write this. R was a constant, so we can say R is a constant. We can write it. Okay. Now, what does it mean? This equation or this relation says us that V1 upon I1. Suppose in this circuit, a special value of voltage is V1 and the corresponding current is I1. Now we change the value of voltage. Now the value of voltage is V2 and the corresponding current in this circuit for V2 voltage is I2. Now we change the value of voltage like 1.5 volt, 3 volt, 9 volt, 12 volt, 20 volt like this. For voltage V3, the corresponding current is I3. Again, for voltage V4, the corresponding current is I4. All these ratios will be equal to a constant. Suppose let us say 5 ohm. Just suppose 5 ohm. Okay. So this means whenever a quantity is proportional to another quantity, then V is equal to Ri, and this quantity upon this quantity, V upon I, will be equal to R. That is a constant. It is a constant. It means whenever you choose the value of V and the corresponding value I, then their ratio will always be equal to a constant like 5 ohm, 6 ohm, 7 ohm, as on like this. Okay. So these ratios will be equal to a fixed constant. Okay, like 5 ohm, 6 ohm, like this. And that's why we use here a constant. Okay. Let us suppose one more example. Let us see one more example so that you can understand easily what is the exact meaning of these steps. Suppose a quantity A is proportional to a quantity B. Okay, let us suppose a quantity A is proportional to a quantity B. Now A is equal to KB, where K is a constant, right? It means A upon B will be equal to a constant like 1.4. Just suppose 1.4. It means value of A1 upon corresponding value B1. If in that case you choose the value of A is A1, then the corresponding value is B1. This relation says us that if you increase the value of B, then there is an increment in value of A. Or if you increase the value of A, there is an increment in value of B, right? And vice versa. It means if B decreases, then A also decreases. Okay, is it meaning? So A1 upon B1 will be equal to A2 upon B2. Again, if you choose the value of A as A2, then the corresponding value of B will be B2. And again, if you choose the value of A as A3, then corresponding value of B will be equal to B3. and these all ratios will be equal to a fixed constant. Let us suppose 1.4, just suppose. It means these all ratios will be equal. Okay, and that's why we use a constant here. Okay, okay, it means a upon b is equal to k, a constant, because these ratios will be equal to a constant. So that's why we we use a constant here, and we write the sign of equal to here. Okay, again you must have a doubt, like this. A proportional to b, then why we cannot write a is equal to b? Or if v proportional to I, then why we cannot write v is equal to I? In your mind you must have a doubt like this: if a proportional to b, then why can we not write a is equal to b? Or if v proportional to y, then why can we not write v is equal to y? Okay, the answer is v is voltage, like voltage, v is voltage. Okay, and I is current. The unit of voltage is volt, and the unit of current is ampere. Is both quantities are same, volt is not equal to the ampere, and ampere is not the same as volt. Both quantities are different quantities. Voltage is volt, current is ampere. Okay, so we cannot write like this: 5 volt is equal to 2 ampere or 5 ampere. We cannot write like this. Volt cannot be equal to ampere. Both are different quantities, and that's why we cannot use the sign of equal to in this case. Always, to show this relation, we will use this v proportional to y. This relation means if value of v increases, then value of y increases. Okay, same case goes to here. A cannot be equal to b. Okay, because maybe a have other unit, b have other unit, both have different quantities, both are different quantities, and both have different units, and that's why we cannot use the sign of equal to here. Always we write like this. This relation says that if a increases, then b increases. If b decreases, then a also decreases in the same proportion, in the same ratio. Okay, so now you understood why we use a constant here and why we cannot use the sign of equal to here. Okay, thank you.